So in this chapter, we're going to consider the macromolecules that make up our cells. The 4 types of macromolecules our cells are made of are things you could find in a nutrition label. So things like protein, carbohydrates, fats, which we're going to call lipids. Is really a broader category than just fats. And then the last group is nucleic acids. You're not going to see those on a nutrition label, but when your food comes from nature, as nearly all of your food does, it's also going to contain some nucleic acids. These macromolecules make up what we call polymers, which is beads on a string. So think of a pearl necklace as a polymer. And they're made up of these repeat subunits called monomers. So as we consider these macromolecules, we're going to learn what the pearls look like, what the individual organic compounds are, and then how they're connected together, what the bond that connects them is called, and then what the long chain is called, what we call a polymer, what that's called. And so of these, carbohydrates, proteins, and nucleic acids all form these long chains of polymers. And then lipids are a little bit less polymer-like, and so we'll learn the subunits of a lipid. So polymers are synthesized. The bond that forms between the beads is synthesized by a reaction called the dehydration synthesis reaction. And that's shown here, where you have this short chain, and when you want to add another, say, amino acid to a protein, for example, a dehydration reaction is going to remove a water molecule between there and create the bond between the amino acids. So dehydration reactions are the synthesizing reactions that form longer chains, put the beads onto the string. And then hydrolysis are the break reactions that are going to break down this longer chain into smaller bits. So that's adding a water molecule to break the bond. And hydrolytic enzymes are abundant, for instance, in your gut, in your stomach, in your small intestine, so that when you eat the foods you eat that contain proteins or carbohydrates or nucleic acids or lipids, hydrolytic enzymes, proteins that help to catalyze this reaction, will promote the breaking of the bonds in those macromolecules so that your body can absorb these freed up monomers, things like amino acids or simple sugars. So hydrolysis is a breakdown reaction. Dehydration is a synthesis reaction. So we're going to look at the types of polymers are found in our cells, but we're going to recognize they come in those 4 broad categories. And then within those categories, there are there's a big diversity. So proteins, for instance, your cells can make about 80,000 different types of proteins. So there's a lot of diversity of the polymers that your cells can make. So we'll give you some examples of very common polymers in each of these categories. So we want to make sure for each category that we know the monomer or subunit or building block. We know the polymer, we know the linkage that joins those subunits, and that we know some key examples. So as I go through these 4 macromolecules, I'll be trying to fill in that information, and that should be something that you have really at the front of your mind by the time you finish this.